Okay. Hello, everyone. This is Krithika again. I'm a product manager for Apex Block Storage at Dell Technologies. We'll take a quick look at deploying Apex Block Storage. So in the previous session, Chad talked about how do you deploy Apex Block Storage. Right now, we are assuming that the Apex Block Storage cluster has been deployed across multiple availability zones, 3 AZs in this scenario. And we'll talk about what happens, how does the Apex Block Storage cluster react when one of the availability zone goes offline or it is stopped. The storage nodes in that availability zone is stopped. So this specific demonstration was executed with SQL Server 2022, but whatever you are seeing here applies for any application, right? So in this example, you will see that we created an Apex block storage cluster with 6 storage instances, and 2 storage nodes were placed in 3 AZs, right? So 2 in each of the AZs. And what we are going to do is essentially make sure that the system is healthy and things like that, and then we are going to take down the storage node in one of the availability zone. So just to validate, we are making sure the system is healthy, the cluster is healthy. We are verifying the TPMs and things like that. Here again, to reiterate, it's the workload here used is SQL Server 2022, but the same thing will be applicable. Whatever you're seeing here will be applicable for any workloads. You can notice that the orders are processing here. You can also see the monitoring and the logs and things like that. Now we are going to forcefully shut down or stop a couple of instances or all the instances in one of the availability zone. We are switching gears to PowerFlex Manager interface. In here, we are going to go ahead and browse for the block volumes, right, using the PowerFlex Manager interface. You can see here that we can view all the PowerFlex Manager volumes, and you can also go verify the SDCs, the storage data clients that we talked about. We are ensuring that all the files that are required are in place. Now we are going back to the PowerFlex Manager, and we are looking at the health statistics, and we are also validating the metadata manager. That's another component which manages and tracks all the data. You can see that the SDS, which is the storage nodes, are all connected. So it is healthy. We are validating that it's healthy now. It's in the connected state. Now we are switching to the AWS portal, and we are ready to start the simulation, right? So essentially 3 availability zones, 2 storage nodes in each of the availability zones. We are going to go ahead and manually stop 2 of the instances in one availability zone. We already stopped one. We are going back again. You can see that the first instance is stopped. We are going to go back and stop the second instance as well in that availability zone. The goal here is essentially to see if the cluster remains healthy and it's able to handle the workload even when one of the AZs completely goes offline, right? You can see that there's a slight dip in the TPM, but the cluster remains online, right? The application is still functional. The cluster remains offline. The best part is once a AZ goes offline, the rebuild happens, the rebuild kicks in, right? And in this specific example, you can see that the rebuild completes in really quick, in less than 30 seconds. You can see that once those instances were stopped, you can see a momentary dip in the performance. But you can see that the cluster returns to the healthy state. And all it takes is 30 seconds for the rebuild to complete. So it is self-healing. The storage node is self-healing automatically. We started off with 6 nodes and now we have 4, right? Because we turned 2 of them. We stopped 2 of the instances, but you can see that the cluster is healthy. Now what we are going to do is, like, we verified that with storage with 4 SDSs, the cluster remained healthy. We are going to go back and start both the instances that we forcefully stopped, right? So we are switching back to the AWS portal. We are going to start the instances which we previously stopped. And this is essentially to see how the cluster is essentially taking up the 2 instances that we just restarted and rebalancing the workloads, right? That's essentially what we are trying to provision. So now you can see that all the 6 instances are in a running state. You can see that there was a slight dip in performance, and it's now back to the normal. And that dip was only during the time the rebuild happened. Workload remains constant. And that essentially shows the rebuilding is happening, right? So we do show the process when rebuild happens. And yeah, we are just making sure that all 6 nodes are back up in the cluster, and it's in a healthy state.